Okay, questions, comments? Okay, the goal today, try to wrap up your practice guide. It's due tomorrow, because that's when our test is. If you were gone yesterday, you know you're paid 188 for students. Test is tomorrow, just so you know that. If you need help, right now, ask some questions today after school, tomorrow morning. All right, well, there you go. Is it need to be in slogan or set form? Y equals negative 3/4 x.
Plus 9/4.
15.
Wait, what did you get? Plus 9/4. This one? Yeah, So, you get that, so then I'm going to put that over to that.
Are you going to school or
Yeah, what's standard for?
before you move the x over to the side of the line.
Yeah, you can. See him and Cat scared me. That's why she's walking away.
Something x.
What's up, Jason? You have football today? You have football today? What? Can I ask?
Did you ask me football?
What?
Did you ask me football?
No. Why, you looking at your last name. Hey, look at that trash can. Yeah, see, this one is from the trash. It's called the intestines, liver, they're all trash.
What?
More what? Spanish?
That chart?
That wasn't homework.
Was it?
It would have been on board. We do have Spanish homework.
We don't.
Yeah, we do. Clear, dude.
Look on Ramsey.
Clear, dude.
It's due. It's in Science Day.
Yeah.
Oh, don't do that to me. You could have said we're getting homework today in Spanish. We have homework in Spanish. I'm scared right now. We're done that, I'll study all this stuff for health and English.
Yeah, Martin Payton told me that.
What happened?
Martin Payton told me that we had a Spanish and study hall. When was it? Handed to us? Oh, it's going to be handed to us today. Oh.
All right, so today we're going to continue on with this idea of doing the maps idea, with a certain distance on a map. So I want to do a quick review of, the major cities map. So let me pop that up here. Let's get rid of major cities U.S. map. Let me gear this map up on top of the board. All right, so here we go. What we did yesterday is I gave you a map, and we had this simple ratio that we used. It was a proportion where we could find distances between cities. So the idea was that you had to use your map. So let me hand these out. You have one. Okay. So you get yours here. You actually put your name on it.
Yeah.
There you go. You didn't put your name on it. All right. Anyone seen Sean today?
No.
Yeah. Okay. All right. All right. All right. So what we did yesterday is we did some examples, and I had 6 problems on the board. I'm going to put them back up on the board here in a minute, just to make sure that you're done. You got it. Okay. So what we did is we did something like this. I want to find the distance, and I'll just make them an example. So find the distance between the following cities. Between the following cities. All right, and the 2 cities were listed, and I had 6, pairs on the board yesterday. I'll put those back up here in a minute. So what we're going to do is we're going to do an example of this. So this will be an example like we did yesterday. So we're going to pick a city like San Diego. We're going to go to San Diego, and we're going to go to
Seattle.
yeah, let's go Seattle. All right, so San Diego to Seattle. So what you have to do first is you have to measure. So take your ruler, measure from San Diego up to Seattle. So do that right now. So let's measure. Remember, go to the nearest quarter of an inch. Don't use the centimeter side, use the inches side. So I'll measure it with you guys as well so you can see this. So San Diego to Seattle. Now if you measure insanely accurately, it looks like it's roughly about 3.25 or 3.5. It's like somewhere right in between. So I'm going to say 3.25 inches. So 3.25 inches. It's closer to that than 3.5. That's what it looks like for me. Okay, and what we're trying to find is the real mileage between those cities. It's quite a few miles. Okay, and then the fraction we used for every single primary state was that 7.5 inches on this map is 2,441 miles. That was our fraction we used. Okay? So how you actually solve this? You start with the number below the x, you cross multiply, and then you divide, and it will give you your x. So 3.25 times the 2,441, whatever that answer is, you divide by 7.5. Okay, does that make sense? Like what we're doing? Okay, once you have that, this will be the mileage that you actually travel. So in fact, I'm going to do that on a calculator. So same calculators here. Go. All right, perfect. All right, so let's do the math. I'll do one on a calculator too. Do you want a calculator as well?
Sure.
Okay. There we go. All right, so same thing. 3.25 multiply diagonally times the 2,441, and then we're going to divide by 7.5, and we get a number like 1,057. So that's roughly our mileage. So 1,057 miles, and there's a little bit extra, so maybe 0.8 miles. Is that kind of what everyone was getting on their calculator? Yep. Okay. Now, what I asked you to do is you're supposed to do that. So whatever the cities I had listed, you had to measure, and that's the number that goes here. That number goes there, whatever it's in inches. And go to the nearest quarter of them, so like 3.25, 3.5, 3.75, which is a full number. And then you cross multiply and divide. And you always find those numbers. Now, what you also have to do, you had to go on Google Maps, not Google Earth, because Earth wasn't working on the computers, but Maps was. So let me pop that up here. Pop up Google Maps. All right, there's Google Maps. And what I did is I just typed in that little search bar. I just typed in San Diego to Seattle, and it literally can just find them instantly. To Seattle. Type in San Diego nuts. There we go. and it will tell you like road distance, right? It'll tell you, how you drive there, how many miles it will take you, and if you take a different path, how many miles it will take you, and it'll tell you a flight. But it doesn't tell you distance, right? And that was the goofy part, like, well, how many miles is it? So what we figured out yesterday is if you take your fingers, so take your mouse, click on Seattle, but you do a 2-finger click on your trackpad. It'll bring up this little menu. Not that menu, but if I 2-finger click on it. Whoa. What did I just do? Now. Are you kidding me? Did I just exit out? Google Maps. Alright. So again, however we brought it up, so let me bring it up again. Oh my goodness. Alright, so San Diego. There you go. Choose Seattle. Alright, so there it is. And if you 2-finger click, there it is. All right, so if you 2-finger click, it'll tell you to measure distance. So if you click, so 2-finger click will bring us up to the secondary menu. You click measure distance, and then you go to some other town, and you click the same thing, distance to here. It'll give you that number. In fact, if you click wrong, you can always like click on these and direct these where you need to. So maybe I want to go. Maybe I need to take this whole guy and go there, and I can get a little closer. And it will actually tell you your number down here. So 1,050. Geez, we got super close. So 1,057 minus 1,057.8. So I was off by like half a mile. Actually, 0.3 of a mile.
Actually, if you put the circle something directly on them.
Would actually be right on. That'd be awesome. Let's see if that actually works. See if I can get really close. Ah, it was close. It was off by 2 miles. Not bad. So that's what you have to do. So you do 2-finger click. It popped up this little distance menu if you're doing it correctly, and then you can click distance. You click on the other side, you don't like to move distance, and you can drag those wherever you want. And then when you want to exit out of that, you just close this distance path, and then now you're ready for the next cities. And what I always did, is I just close this little box here, and then I just type it in again, like whatever the other towns were, like Chicago's or whatever. Okay? And it always popped up. It always showed me the 2 cities like centered on the map. It was just perfect. Okay, so that's what you have to do. So I always wanted this, and I also wanted what did Google Maps roughly say. So that's what Google Maps said. 1,059. So I wanted both answers. I wanted to know what your map showed and what the Google Map showed. The weird part is when you go north to south, sometimes the numbers are a little bit off compared to east and west. The reason why is that going north and south is actually technically a shorter distance on a globe than it is going east to west, because the sphere of the Earth is actually compressed north and south, so the distance was a little bit off. Just a hair. We got really lucky with San Diego and Seattle. They're almost directly on a line of longitude, so they're almost perfectly straight north and south. If you were to pick some town, like if I were to pick Phoenix to Seattle, it's a little bit off-center, so the distance will be a little bit weird. But you'll be close. You'll be in the ballpark. Okay? All right, so I'm going to put those cities back up on the map, or back up on the board here, so you can find those distances. I want you to double-check, make sure you finished them, make sure that it's on a separate sheet of paper so we can actually turn that in. So this is how I did mine. You can see it. I wrote down what the city was, I wrote down all the math, and I wrote down what Google Maps said, and then I did the next problem, and I did the same thing. So I did one problem after another, and I numbered them off. So I'm going to give you those cities right over here. So I'll find the distance and the Google Maps setting. So if you need to, make sure that you were correcting that. distance to cities. All right, so here's your 6 problems one more time. After I give you some time here, we're going to discuss how we can change this problem a little bit different. And we're going to do just a few examples of it. So the first problem was Chicago to Denver. Second problem was Seattle to San Francisco. Third problem here was New Orleans to Washington, D.C. Now remember, Washington, D.C. is the capital. It's over on the East Coast. It's not Washington State. That's something we'll kind of talk about. Number 4, San Antonio to Boston. And that's why it's nice to have a computer out, so if you don't know where these cities are, you can type them in, and it'll actually tell you the major city where it's found. These are major cities. Like, I'm not looking for like a weird Denver, Iowa kind of thing. Number 5, Minneapolis. Minneapolis to Phoenix. And the last one, number 6, New York City to Nashville. So, double check. Are you giving me the correct distances according to our fraction here? So you're measuring with a ruler, you're doing a little cross products, finding those distances, show me that work, and then show me what Google Maps said. That's what I want. I want it both on one piece of paper, make sure your name's on it, and then we're going to add a few more problems today. Well, I'll give you a little bit of time here if you need to make some fixes, or maybe you didn't even have it on paper. It's not written on the map. It's got to be on a separate sheet of paper. Or in the map or something else. So if you're done, hold on to it. We're going to talk about some new problems. I'm going to add on a new problem today. About 5 minutes here we can kind of work on these. Remember, using that same fraction, that 7.5 inches is 2,441 miles for each one. You have to measure and then find out the real miles, and then use your Google Maps to see what their distance is. Okay? If you don't know where the city's found, type in Google Maps. It'll tell you where that city's found, the first major city. Let's go to lunch. Go back, we're going to start a different type of ground with the same structure. You're gonna like this next. This next one's pretty creative. Okay, you'll definitely need your Chromebooks for this next part today. Definitely need your Chromebook. Alright, let's see. Here's your study guide for today. We're going to need to talk about these last few properties. So, we went through every field property, all 6 of them. So now you need to get caught back up. So, I haven't posted a video online. You most definitely want to check that out. Yeah, this video.
What's that website that you want to watch that again?
HS Math. Alright, that should be easy enough.
How'd you get that? That website address cost like
Cost me a lot of money.
Wow. Pretty cool, actually.
Alright. Okay, here's what I want you to do. This is going to seem a little odd. I'd like you to go on Chevy's website, and I want you to search for their car called the Bolt. The Bolt is their new electric vehicle. I want to know the particular range of that car. How far does the Chevy Bolt travel on just battery power? Because it doesn't take gas. That's what I want. Now, it's either called the Bolt or the Volt. I'm not quite sure. I want their all-electric, not the hybrid where it uses gas. So Bolt or Volt. So let's do that right now. Let's see what you got.
I didn't know we had an all-electric car.
Yeah, that's their newest one. It's coming out this year. So. So, put up here, so Chevy Volt or Bolt? I want the all-electric. Bolt? No. Or Bolt? Bolt, okay. And it was one or the other, so it makes sense. Volt for voltage. Volt or Bolt? Oh, there's two? Okay, so it's either or. Okay, here's what I want. So if, no matter which car you look at, they're basically the same. I want the all-electric car, so probably the EV car, if you're going to look at the Bolt. I want to know what is the range that car can travel without running out. Like, is it 300 miles? What is it? 230 miles. Okay, so let's assume that's the same for both cars. I have no idea. This is their new car coming out. Okay, I like the idea of electric cars. You're not using gas. All right, so let's say it's 230. If you find a different number for whatever model you're looking up, that's fine. Okay. All right, so let's assume it's 230. Now, why this is important? Okay. What we're going to do is we're going to reverse this problem around. I'm going to give you a city to start in, and I'm going to ask, where can you travel from there? So we're going to start in Garner, Iowa, and I want to know what towns can I hit traveling in that car. And so what we're going to do is we're going to do this. We're going to do the same problem, but now we know the mileage. We can drive exactly 230 miles. What we don't know is how many inches on the map we can actually travel. So you're going to reverse that problem around. So take your calculator right now. Let's see what you get for inches on that problem. And it's going to be a decimal. That's completely fine. I expected it to be. Right?
0.0
0.7, right? So 0.71 if you round, right? So the x is 0.71 inches, right? Now what that means is that that's almost 3/4 of an inch, 0.75 of an inch. So what you're going to do on your map, take your ruler right now, and this is going to seem a little goofy. We're going to start with where Garner's at. So here's Garner. So Garner's right above the A in Waterloo, basically. And I want you to measure where 0.75 of an inch is. Now 0.75 is the major mark on a ruler. It's you see where School Smart is? It's the mark right off the T on School Smart. So you're going to mark that distance, top, bottom, right, and left of Garner, using that inch and a half, or sorry, 0.75 an inch, 0.75 an inch, 0.75 an inch, 0.75 an inch. And you're going to mark that in all distances. Once you have that distances marked, I want you to draw a circle connecting those. Like that. So you're actually going to draw on your map with pencil. And what I want to know is, what city can we hit? Major city can you hit? Okay? So in fact, I'm going to do it right now on this map. And then I'm going to take a picture of this so you can see how I did this. So you're going on your map, you're measuring 0.71 or 0.75 inches with your ruler on your map. You're marking that distance right, left, top, and bottom of Garner. And Garner's right above the A in Waterloo. Now I'm going to take a picture of this so you can see what I did here. All right, so I'm going to take a picture of what I just did here. So again, we're going 0.71 inches from Garner. Now I'm going to take a picture and I'm going to share this with you so you can see this. Again, this is just a rough drawing of what we're doing. All right. Share that. All right. And I'm going to show you where this goes, and then we get to the actual picture here. I'm going to show you how I did it, because this is what we're doing. We're reverse engineering the problem to see how far can we actually travel. There, all right, here we go. So this is, I'm gonna open this attachment so you can see this. So here's what I did. See if you can see this. Now this is, again, really rough sketch. Now you need I'm gonna bring it back. Not as fast as there. Okay, so Garner's right above the A in Waterloo. I went 0.75 inches. So 0.75 an inch. Ruler is here, and then I marked down here, to the left, top, and I do a rough sketch of where it hits all three spots, top, right, left. This is your hypothetical range that that car can travel without you having to charge it, without using 0 gallons of gas, right? So what were the major cities I could have hit, like on the outside of the circle? Obviously, Minneapolis I can definitely hit, but I'm talking about like the farthest range I could have got to. Madison, Lincoln, yeah, Davenport. Not quite Kansas City. I've probably been a little short, but I'd say probably the two most accurate places, Madison and definitely Lincoln. Those are probably the closest to the edge. Those are the biggest cities I could have hit, other than Davenport. Okay, does that make sense? Okay, so that's reverse engineering the problem. You know your range your car can travel. I can tell you what city you're going to go to. Okay, that's the type of thing. Okay, all right. So now, here's what you're going to do. I'm going to give you 3 problems today. And I want to see what city, what major cities or city you can hit by using a hypothetical electric car without charging it. So I'm going to give you the car, so you have to research it. You have the map, you have the ruler in front of you, and I want to see what city or cities can you hit with that car from the certain town you're leaving from. Okay? And I have a bunch of different towns listed here. So, here we go. So here's the car you've got to look up and see what city you can potentially hit. So the first problem we're going to start with, so this is problem number 1. We're going to start in Detroit. Now, if you don't know where that's at, you're going to have to research. And you're going to try to figure out what city or cities you can potentially hit. The car you're going to be using is a Tesla Model X. A Tesla Model X. Now, I know there's a bunch of range of Teslas. There's the P90s, the P70s. Just pick one of them, okay? They're all about the same, okay? The second city you're going to leave from, you're going to leave from Orlando. You're going to leave from Orlando. And the model of the car that you're going to be using is a Tesla. Again, that's all electric. But you're going to be using the Model 3. That's a car that comes out later this year. And then the last problem, the third problem you're going to be leaving from Reno. And you're going to try to see what city can you get, and the model of the car you're using, obviously a Tesla again, you're using the Model S. Drive themselves from start to finish. That's what's interesting about those cars. But I want to know what city or cities can you potentially hit by using that car and only charging it once. So you charged it, you drove from that city, where can you go? Now the problem is you have to know what city it is, and you got to go research to figure out the range of that car. Just give me a hypothetical range. Then you're using this formula. So whatever your range is, that's the number that's going here. So maybe you can travel 400 miles, that goes here. Maybe you can only go 100 and put that there. And I want to know what city or cities can you hit. So you're going to have to draw. You will have to draw on that map. That's why I didn't want you drawing on it yesterday. I've done this to a bunch of different cars, but these cars are by far, I think, the most accurate. They've been on the market for almost ever, except for the Model 3, the new car.
They give them like a range, so
Yep.
it's like 200 to 289 miles.
Give
just
me
like
the max.
average.
Give me the max. Yeah, if they give you a range where that car can travel, use the max number. Because that's, in theory, what that car can potentially hit. Because they're underestimating that car, because they don't want to overestimate it.
Mr. Ward, you know at the beginning of the year how we were talking about prices, or like how much a teacher would make in 1 year, right?
Yep.
How many years would it take to get $74,000?
Teacher salary, like a new teacher salary?
Yeah.
3.
3 years?
3.
You could buy with a Tesla Model X. Right?
In 3 years.
If you use your
If you use the entire salary, that's not taking out taxes. If you took out taxes,
Probably triple.
Double.
how much was that car?
74,000.
That's what they start at. Yeah, about 3.5 years.
Man,
That's what we're paying
That's-
taxes.
That's with paying taxes, but that's not spending any money on anything.
so
Said
you had
every
locked up for a
penny.
while, you're gonna get that. That's crazy though. Man.
So if you
The,
go,
the good Model X is almost 150.
Wait.
The P100D ludicrous. That car is faster than any production car on the planet.
Even the Bugatti?
It's faster than Bugatti.
Oh.
On a straight 0 to 100,
Damn.
it can hit 100 miles an hour in 2.6 seconds.
Okay.
And it can stop faster.
Have you heard of a video like where a guy builds a machine in like a saw and then he puts his finger right over it and it stops really quickly? And that's like better.
So, the cool part about those cars is this is the funny thing that they do on the test tracks. Is that car is literally faster than any car production car. It's electric, no gas. Faster than Ferraris, Lambos, Bugattis. Bugatti has a faster top range, but it's not quicker off the line than the Tesla. What they found is that companies can actually make their car faster. Like Ferrari makes like a 458, 488, the Law Ferrari, like the fastest cars on the planet, right? Those cars are actually faster if you put them on a trailer and you hook it up to a Model X. You put the car on the trailer and the Model X pulls it down the runway. It's actually faster.
Do you
Than
think
the original car itself.
do you think the reason why the Tesla is faster is because it's electric?
It's all electric. It's got 4 engines. They're independent. Nothing needed. You can go from 0 to 60 instantly. Right there. It's instant torque.
the batteries.
It won't spin tires. It will literally go from 0 to 60 instantly, and you're
Well, that's
rocking back in the seat.
Well, if you're gonna go to 0 and 100, that might have a lot of batteries.
It has to have a lot of batteries. Now, if you're doing that a lot, you'll kill the battery life. You won't make it 280 miles. Make it like 50 miles. They're considered the fastest cars on the planet, like acceleration.
Just imagine 100 years we have like crazy cars and like.
And the best part is they can drive you. They can take you wherever you want. You just type in the address and the 17-inch touchscreen on the car.
Yeah, I go to Florida, just sleeping my whole way there.
Right now, it doesn't have that feature. That feature comes out December next year, and those cars all have it built in. It has to work correctly.
I have the
I don't think
one.
I can trust it.
Nah, I've seen it before. Right now, it's not there. It can do lane lock and keep you in the lane. What the problem is, it has cameras front, side, so it knows kind of where cars are. But what it does is it does this little true thing where it watches the lines, but when it doesn't know the lines, it follows the traffic in front of it when it can't see lines. Like when they just roads around here, you can't see lines because sometimes lines are printed. So it will follow the car in front of you. So if your car decides to turn, the model will turn with it.
So you could end up somewhere completely
Yeah, you could
different.
end up somewhere where you didn't think you were going.
Well, like with the cars on the left side going that way, could it just turn around and go that way?
No, it will just avoid the cars.
Crazy.
No. Pretty cool. Doors, gold wing doors, they open upwards like it's a line. Very cool. I want one, but I can never afford a car like that. I can afford the Model 3. That's my price range. Model 3 is about a third the cost of the Model X. They start at like 25. I can afford that car. That car comes out in December.
Model 3 doesn't look that bad, you know.
No, it's a good looking car. I don't like the front end, but
Just imagine you come to school in something with, everybody be over your car.
it'd be cool. I like the interior. The interior of Model 3 is something that's so important. There's no gauges, nothing. It's just a touch screen in front of you. That's all it is. Yeah. This is a fun little exercise. Figure out this, and we're going to look at real cars other than these electrics.
Man, the company Tesla has a ton of money over here.
Because they have to destroy the car first. Like they build it and then destroy it.
Yeah,
To
there's
have it
guys
all
out
built
there.
and then just watch it crash.
That's probably one of
put them into machines that tell you kind of theoretically what it'll do. Trust, but yeah. The Bugatti Chiron that's coming out. Chiron comes out December this year. There's already a couple in the road. Those are happening 6 now. And right now they're selling on the market because people already have their reservations. They're going for like 7 now. Now people are actually selling the reservations. Because the reason why they cost so much is the festival plan because they go like 300 and something miles an hour. But they're limited production. They make like 200. They never make them.
I wonder if that's enough money to buy.
Really? They don't keep making them?
No, they make 200. They're done. Then they move on to the next car. That's how they make limited numbers. That's why Ferraris cost so much. That's why Porsches cost so much. They make limited numbers. Highest number that they'll ever make for like a Ferrari is 1,500 cars. And they don't make it forever. And then they do the next car. So that's why there's certain collector cars that are worth so much because they get a limited number. So somebody that has a lot of these cars like Jerry Seinfeld.
Like the Mustang GT off.
Yeah.
Yeah, I mean, like,
50? Yeah, something like that.
about 25 grand.
Le Mans cars, like Porsche Le Mans cars are worth like 100 millions. Jerry Seinfeld has one of 3.
Can't even comprehend that much for me.
Yeah, for a car.
Man, why do cars cost so much?
Do you want us to keep this?
Yes, so you need to figure out hypothetically where that's going to be now. I need my ruler back, so you don't need to keep my ruler, and I need my calculators back. So if you need to, you can work on that some other time, but obviously ruler, you can use any type of ruler that you need to. But again, goal tomorrow, come in with those hypothetical cities we can potentially go to. Then we're going to look at a real car. How far can a real car travel? As opposed to what?
Just imagine they make the first ever motorcycle that has autopilot.
What?
I don't understand why in Ventura they have this guy says like 200 some miles per minute. Like it makes no sense to me.
I like it.
Like who even goes to Wisconsin like on a daily basis?
Are we social studies?
Mr. Ward? Right, is there any other people that are in? One?
You mean...
You guys have your quick?
Yeah.
Yeah, it's not
What time do you guys leave then?
12:30.
So like only 7 minutes before the class ends, but...
What was that?
Still gonna have time. Why? So we can make fun of you tonight. So I ruin
Like
speed,
you
like
like
that
a
showing.
Wins for 2 feet.
Take some medication. Get
Just
to
like the
school. I
fire.
did.
Matt, watch me squint.
It wasn't even what I did.
Go 10 girlfriend of it. 10?
I can't mimic what you did. That was...
Well, that's your problem. You're probably gonna die here soon.
7.
Nice shirt, Tucker.
Where's your bed, buddy?
I'm sick.
What else? My tractor.
Why?